All right, so this is 7-6, solving radical equations. Owen, I know it says 4-6 in your notes. It was like a typo, so my bad, just make it 7-6, okay? Or 7-5, I forget what it is. All right, but either way, it's solving radical equations. So up here it says isolate the radical, then eliminate by raising both sides to a power. Be sure to check for extraneous solutions. So there's a lot of things going on here. First things first, Zach, all throughout math, we've had like adding and subtracting undo each other, right? Multiplying, dividing undo each other. Now we have squaring and square roots. They undo each other. Cubing and cube roots. They undo each other. Does that make sense to you? All right, so we have all of these operations and they need to undo each other. There needs to be like a checks and balance, okay? So in order to solve this, what I need to do is I need to get x by itself, just like we did before. So how do I get rid of that -8, Zach? Add 8. Now when I add 8, I get the square root of x equals 8. All right. And I always like to stop and, as my college professor would say, is like wallow in the math and smell the roses, if you will. Okay, I like to look at it, just make sure everything's nice. Okay, meaning like, do I have any extraneous solutions, like things I might not get? And a lot of people will get to like a point here and they'll say like the square root of x, and let's say it equaled -8, and they'll say no solution. All right, but in this case, we can have a negative for an answer here. The only thing we can't really take the square root of yet is a negative number. We talked about it, they do exist, but we're not there yet. Okay. It's coming, it's just not there. So Zach, to undo the square root of x, we square it. All right, and I think you already knew the answer was going to be 64, right, Zach? Because the square root of 64 is 8. Make sense? Okay. And if that was a -8, we would still get 64, because the square root of 64 could be a +8 or a -8. And that was one of the questions on the test. All right, so I'm kind of like giving you a hint. Some stuff might have a positive answer and a negative answer. All right. Now let's look at the next one. Emily, with this one, how do I get rid of +6? So I'm going to subtract 6. And that gives me the square root of 3x equals -6. And this is where, Emily, a lot of people stop and say like no solution, but we can have the square root of a number be negative. All right, think of it this way. The square root of 9 is 3, right? Because 3 times 3 equals 9. But -3 times -3 also gives me 9. And that's what this is saying. I can have the square root of some number be negative. So Emily, how do I undo the square root? Yeah, I square. And the one thing I want to mention to Mark and Marcus is this. Notice it's in parentheses, right? Mark and Marcus, see that? Got to keep it in parentheses. If I drop the parentheses, -6 squared, no parentheses, gives me -36. -6 in parentheses squared gives me +36. So I get 3x equals 36. And Emily, would you agree that x equals 12? Here we go. So far, so good? Doing all right? Rachel, you doing okay? Yeah, you going better since lunch? Or did it just go downhill? Always good. Always good. Lunch, low point of my day. Low point of my day. Gotta tell kids to sit down. The worst. All right. Mr. O'Donnell. We were talking about square roots have like an undoing function, right? Which was squaring. What about cube roots? How do I undo that? Yeah, we cube it. So first thing I want to do, Mr. O'Donnell, is I want to move that -2 over. So I'm going to do that by adding some. That gives me the cube root of 2x plus 1 equals 5. You good so far? And then you told me that to undo a cube root, I cube it. What is 5 cubed? It's 5 squared. Did you say 25 or 125? The 225? It's a little smaller. 125. Okay. You were thinking of 15s. All right. 15 times 15 is 225. It's easy. It's a mistake. So it's 125. So 2x equals how much, Mr. O'Donnell? And then 124 divided by 2 is, off the top of the dome, 62. You okay with that? All right. Sarah, you good? All right. Sarah, in this fourth problem, okay, here, how would I undo those square roots? I would square them. All right. So notice, I'm not trying to get the variables by themselves. I'm kind of trying to get the square roots by themselves. So I go ahead and square both sides. So I have 5x plus 3 equals x plus 11. Jagger, you okay? Now, Sarah, what would my next move be? Subtract the x from both sides. I have 4x equals, or 4x plus 3 equals 11. Then I get 4x equals 8. Divide by, and I get x equals 2. And Sarah, like I said, I always like to stop, look back, make sure everything makes sense. I plug it back in. Does it work? All right, can I plug 2 into that? And I can. All right. Okay. Now let's talk about this one, the last one of the day. All right, we're going to do it 2 different ways. Maggie, so I'm going to need your help here. Now, Maggie, I have something to the 4th, right? So how do I like undo the 4th root? Yeah, I gotta raise it to the 4th power. So you're right on that front. Do I just raise both sides to the 4th power, or do I have to do anything beforehand? Yeah, so I need to pick one of those 4th roots, and I need to get to the other side. Because if I were to just raise it to the 4th power right here, what's going to end up happening is it's going to end up creating more terms. Okay, for example, let's look at like if I have the square root of 3 plus like the square root of x equals 0. Okay. All right, this is just for example, you don't have to write it down. If I were to just square both sides here, this is going to create a lot more terms because they're going to have the square root of 3 plus the square root of x times the square root of 3 plus the square root of x. And then I have to FOIL that. Does that make sense? But if I do what Maggie said, and I get one of those terms to the other side, when I square it, just the radical goes away. So Maggie, it doesn't matter which one you move, but you got to move one. Okay? So Maggie, I want to get rid of this 3x because it's smaller and less to right. Is that okay? So that gives me the 4th root of 2x minus 5 equals negative 4th root of 3x. And then Maggie said, well, I got to raise both sides to the fourth. So I'm going to go ahead and do that. This is easy. The radical and the power just cancel out. But now, Maggie, I got one question for you. That negative outside, right? That gets raised to the fourth too, correct? So what is -1 to the fourth power? 1. And that's what you need to make sure you understand. Is that that power goes to numbers outside as well. So -1 to the fourth power is 1, and then the radicals just cancel. So I have 2x minus 5 equals 3x. Where do I go from there, Maggie? And I get -5 equals x. And I'm good, right, Maggie? All right. And I heard a little hesitation there, right? Because there's probably a catch here, correct? Now, Sarah, don't put it away. We're not done. We're not done. All right. You know me, Maggie. There's always a catch, right? Always a catch. One of the problems there has to be like a catch. Now, Maggie, I numerically got an answer, right? But I do have to check these to make sure that I could actually, have that as an answer. So Maggie, what I do from here is I take that answer, that -5, and I'm going to plug it back in. And I can kind of stop right here. And here's why, Maggie. 3 times -5 is -15, right? Can I take the fourth root of a negative number? No. I can't take an even radical of a negative number at this point. All right, so like if I were to plug in the fourth root of -15, it's going to say error non-real. So this is not a solution. And my answer is actually no solution. All right. Now, here's one more way to show you and prove to you there's no solution. Can I erase some of this? Sarah, am I good to erase it? All right. All right, I need everybody to get out their calculator. All right, so everybody see like in the work, Garrett, do you see where I got to this point? Okay, now with your calculator, we're gonna actually type some stuff in. Doesn't take long, but it does show you and will justify to you why it's no solution. So I already typed it in here, but I'll show you how I typed it in. Okay. Now I have 2 functions. Marcus, I have 2 functions. I have this one and I have this one. Okay. And they're equal. I'm asking, when does this function equal this function? Garrett, does that make sense? So if I type in up here into the first slot, the fourth root, so for math, go down to number 5. Then I type in 2x minus 5. You okay with that, Sarah? Did you already type it in? Oh. This one gave me a lot of prompts to type in. This one, I actually have to type it in kind of weird. So I have to do for math. All right, 3x. And then I have to go all the way back to the front and type in that negative. Now, oh, and do you see how my 2 functions are these 2 functions? I hate graph. Oh, and this top function is this function. This bottom function is this function. Look at the picture. I'm asking, where are they equal? In order for them to be equal, they have to cross, correct? Do they cross? That's why it's no solution. Any questions with that?